Lesson 16, the trapezoidal rule, number 1. Now this diagram shows the first quadrant of the ellipse y equals square root of 1 minus x squared over 4. Now we have to work out the approximate area underneath this curve, but first of all we need to complete that table. Right, now to do that we're going to substitute these values in. 0 has been put in and we've got 1 and so on. Now just pause the video and substitute those values in and see if you get the correct results. Alright, now the first one, you're putting 0.5 in, you should have got 0.968. Number 1, you should have got 0.866, and in 1.5 you should have got 0.661. Right, now in part 2, by using the trapezoidal rule with 5 function values, we have to estimate the integral of the square root of 1 minus x squared on 4 between the limits of 2 and 0. Now that means that they want the area underneath this curve. Now this is the first little trapezium here. Now we'll take each of these ordinates and we'll label them as y1, y2, y3, y4 and y5, and I'll just put that underneath here. I'll write that as y1, y2, y3, y4 and y5, just so we don't get muddled up. Now this trapezium, take the first one. Okay, that one there, going down a bit this way. This is your y1, this is your y2. We've got to call this distance here h. Right, so that's h across there. So the area of a trapezium, as you know, is the area equals h over 2 into y1 plus y2. So this one here would be h on 2 into y2 plus y3. So you have a y1, y2 there and another y2. So if we did it in one go, we'd have the area is equal to h over 2, because that'll be common throughout, and it would be y1 plus 2 times y2 plus y3, because this will double up, plus y4, and plus the last one on its own, y5, because all the doubles would be here, here and here. So all that remains now is to put these values in, and we see that h is consistent throughout. It's 0.5, 0.5 on 2, and to y1 is 1. That's why you have them down here so you don't get muddled up, plus 2 times 0.968. I'll just rub that bit off over there. Alright, now we're back to putting these points in. So now we're going to have plus 0.866 plus 0.661, close your bracket, plus 0, and that area is equal to 1.4975 on your calculator. Right, now in part 3, given that the equation of the ellipse is x squared on a squared plus y squared on b squared equals 1, and the area of the ellipse is pi times AB, find an approximate value of pi. Now first of all, we have to take this equation and rearrange it. So we'll square both sides. So we'll get y squared equals 1 minus x squared on 4. So this becomes x squared on 4 plus y squared equals 1. So this is in the same form as this one. So a squared is equal to 4, making a equal to 2. B squared equals 1, so b must be equal to 1. So this value here is 2, and this one here is 1. So the area we found here, this is the area we found here, so the area of the total ellipse will be 4 times that. So the area of the ellipse is 4 times 1.4975, which gives the result of 5.99. Now, we know that the area of the ellipse is pi times AB, and so it'd be pi times 2, and that's equal to 5.99. So on dividing both sides by 2, we get pi is approximately equal to 2.995. Now we know pi is greater than that, but remember this is the trapezium. We're applying these little trapeziums, so we're going to have an underestimate all the way along here. But in the next video, we'll apply Simpson's rule, and you'll see we'll get a far more accurate result.